Let's get started. How we made our robot. So first, like we decided we will make something like a bulldozer, and there will be a container at the back. So basically, it would pick up stuff with its bulldozer claw. It would come up like this and throw it back in the container that we would make. That was our first idea. So we started building that. Okay. So it was sort of something like that, but with the container at the back. Okay. But then we decided to make it like with the container. We decided like have a base, because like first we decided like we'll have no base, so it would just be Lego parts. Then we actually made a base. Then we put the walls and claws together. So we actually made the paint, and then we changed our idea completely. It didn't work. Okay. So since it didn't work, we were sitting on a table. One person had a paper, and we were writing all our ideas down. Okay. And then we decided that there would be a robot like this, and there would be 3 walls like this attached.
So it's like that with a wall.
And then if like this was some jump, like if there were jump, it would, like the wall would cover it. There would be a motor turning to
fourth wall.
And
then
then
the motor makes it turn up, go forward, collect, and come back.
So are there attachments that you can use at the moment?
No, it's coming.
Yeah, but then again we changed the idea completely.
One of the students just run off down to the classroom to get it.
Then we changed our idea again. So then we made this.
So this is what we are decided on again. So basically there's going to be a claw, sort of like this. A claw with a motor. And a claw will be here. And then there'll be a motor from here, which will have a wheel. So that every time the motor moves, the wheel will just rotate, the spin on that.
So how many missions have you selected? Four missions? What missions are you getting?
Separator, the methane,
This one, the methane, this one, and the demolisher.
Okay. The water. The compost,
the Korea.
sorter. The compost, the sorter, the demolition, and
Methane.
And the one with that push.
And how many
The
programs?
pendulum.
How many programs have you put together for your missions? Program as in programming. Yeah. Okay.
Yeah.
Few one, but then
we still work.
We're going to divide it into probably 3 or 4 parts.
Okay. So can you be able to put the motor and the attachment to make the claw work at this point?
Yes.
Or no, it's in the design stage.
We have an idea, but we've not exactly completed it.
Okay. So is there as of now for 8 runs for tomorrow? You said you're doing 4 runs. So is your robot ready to do a couple of runs for tomorrow?
Yes.
We just have to put some few
Minor
claws,
adjustments, yeah.
and we have to put the motor. Motor the robot's complete here. What have you used for the robot?
For now, we just use 2 motors, and we've used gears for the wheels to move a little faster. Then these are just we've only used 2 wheels, and these are just for guiding wheels. Then this is currently the front of this is the front, this is the back.
Okay.
So this claw, we're planning that we've not 100% finished the claw yet, but ideally it'll just go through the hoops of the methane, and then it'll just collect them and drop them into the car.
So you guys are going to be ready for tomorrow with your claws and all?
Yes.
And what are your target model for turning?
Because there are 2 motors,
So whenever we need to turn, we just move one motor to move
faster than the
it.
other.
One motor doesn't move, or one motor moves backwards, one motor moves forward, so it turns like this.
move when?
Oh, that's why we have an ultrasonic sensor. Every time it hits now we're using 2.
2 sensors. Both are ultrasonic.
No, one's ultrasonic, one's color. But we might be using 3 sensors, we're not sure.
How ultrasonic sensor works?
If it detects a wall, it'll take a turn.
How did you decide on this and not the sign or the...
Why not other sensor? Why only ultrasonic sensor? How it
There are more
generates
sensors. How did you zero down when you wanted an ultrasonic?
There are more sensors. The color sensor is on the side, as you can see.
Yeah, that is a plus sensor, right?
How did you come up with this ultrasonic sensor? Why did you use this and not other?
Well, they Me and Sarthar, we both are programmers, and there's two more guys who are going to be choosing for programming. I just chose to put the sensor down there so we can detect if for a wall it would turn, but
Also,
if we detect any of the methane things, it will act. If we have a motorized
so
car,
like
it will
if
act.
you detect something other than,
The wall.
let's say if this is there, this is the wall, it will detect the wall and turn. But if it detects another, let's say this is not the mission it's supposed to complete, so then it will also turn. So a color sensor won't help with that. It will be better with an ultrasonic sensor.
How it generates ultrasonic inside this? How it generates ultrasonic? It has got the receptors. Because it has a crystal and that mechanism, the light came and applied. Okay.
Is this your first time?
No, it's my third time, but the rest time it's first.
It's our first time in FLL.
I've been doing FLL in the US, so this is my first time in India.
And what was the biggest challenge in putting the robot together?
The claw, I think.
Deciding
Deciding what we're going to make.
claw
Like
or the
we changed
wheel
twice.
or the carriage or the bulldozer.
Basically just the whole
Parts of
bending
the
part.
And in programming and software, what was the
The programming, the problem is that when you're programming it without knowing what the robot's going to end up like, you come into many compromises. Like, say you were planning on making, say you thought the robot's going to be wider and shorter. You don't know how tall it's going to be. You don't know where the sensors are going to be kept. So it depends on how high the sensor is. Like,
So it becomes
say
a little hard to program it.
So how did you decide, how did you overcome that? How did you come to the position
we
of your
just-
current center?
we just waited until they finally decided on what's going to happen with the robot, and then we started to program.
So we sort of tried to communicate a little better. So once we started communicating better, we all formed our ideas better. So then we could tell them what we were planning, what the sensors were planning. And then we all decided which missions we're going to do together. So then I think we got a little closer together, like onto the robot. So then accordingly we could do it much faster and better.
So the for programming just two and rest.
No, there are 4 people for programming.
What you did in this?
Designing, building,
I
presentation.
did the building part for this. Like,
I had built
Initial
the previous, built the previous models, but this model was like
He built the claw.
this was
Okay.
That part.
and
He asked the best questions, honestly.
Do you have your program? Can you walk me through your program?
We don't.
it's on my laptop, but I can't open it right now.
And we decided a name for it. We actually had to think a lot.
The robot's name.
And the robot's name is
Wobbly.
Have you completed this or is there some other piece that you want to show us? What is one unique feature that you would like to tell us about?
It has a claw and a wheel which spins.
So that turns that we
It has
on the
multi
separate.
features and
Would
the
you like
same
to give
part.
us a demo of one of your favorite missions?
but we
Uh,
Our
Program
program
isn't ready
isn't
yet.
completely finished yet.
So
we are sure you'll be able to finish it by
Yes.
tomorrow.
Yeah.
Yes.
What struggle did you face in completing it? I mean, where are you stuck? What is your biggest challenge that getting this together?
It's gonna probably the program. Though we have the basic program like the exit and re-entry for like one of the easier programs, but the harder one like getting the methane gas, it's a longer distance, and then you have to program the robot to know when it's the wrong time and when to move away.
Okay. So, you guys must have done the practice runs. Have you been able to do any practice runs on your 4 missions so far?
not
We're going to do it today.
When did you guys start preparing or planning for this?
2 days ago.
Yesterday.
2 days ago, it's been sure. I thought it was at the end of February.
Like we started basically yesterday.
And we received our kit
This
yesterday
week
evening when they'd all gone back home, so this is our
And
first
now
year.
this is the final event.
So how did you guys got to know
This is
the
practice
game?
design.
We started before you came.
I don't know. I'm certain it was at the end of
There's a
February.
number of different things, and one of them being that I thought it was the end of February. So our robotics club, where we were going to move on, we were just finishing a sumo challenge, and then we were going to move on to prepare the robot for this challenge. But unfortunately, then I find out on Thursday that we've got the competition. Friday was a state holiday, so the school was closed, so they all came in yesterday. But
I
thankfully,
like your enthusiasm, right? In 2 days, I think you've been able to put
Thank you for taking that into consideration.
Very, very important. I like the presentation that you've been able to put your concepts together. I'll ask you this. So far you haven't done a practice run as such. So how did you guys zero down on these 4 missions? Why were you
It was
the simple
since I've gone to 3 different Lego robotic FLL tournaments. I basically even now because they usually use the same kind of mechanics in each one. There's a different layout and different reason to do it. So the mechanics are easy. I understood how the largest one works. The one which you have to you can have keep on spinning it. I found out how it worked in 2 seconds because I've been using it because I've been doing FLL for a long time.
And we all already knew what the missions were. So like we knew what the missions were, even though we've not done it before. We were a little bit like we were comfortable with what the missions were. So first we experimented with each mission and how the robot was gonna work. So like we put the robot
Only the
down.
concept
Then
have
the concept of that okay, this has to be
So
placed
it
there.
was a mutual decision to zero down on 4?
Yeah.
Or
Yeah, it was
guys'
mutual
experience
Yeah.
was there?
Mutual. Everybody decided together.
I
would
would
also
like
we also follow the design cycle. I mean the design cycle.
What
So
confusion?
first get your thoughts in and then your plan
We designed
We did everything
we did the
together,
flowcharts,
come
all
back,
the sensors,
and we could
movements.
reprogram it and
I know we've run out of the time.
motor again. Is that allowed?
Great effort for 2 days, immense effort, and great in the right direction.
It goes back to center breaks the white part.
He is asking that he has one question. Yeah.
Yeah,
Good
actually,
questions.
Savar said that when you, that there was this rule in FLL that you could make.
I'm gonna explain what I mean because he can't explain it properly.
So, it goes here.
Coaches are not allowed.
Pardon?
Yeah, coaches are not allowed in the game.
Oh, right.